Section 6.3 homework problem number 8. In this case, we're dividing by 45, and 45 is not like 25. It's not really a special number. So in this case, we not normally would kind of go back to the traditional way, which can figure out how many hundreds are containing, how many hundreds of 45, or how many tens of 45, because multiply 45 by 10 or 100 or 1,000 is easy to do. And of course, for a normally we could do a long division or the scaffolding method to figure out how many hundreds of 45 are containing here. But if some students have trouble seeing how many 45s are in here, this is a possible alternative solution. So let's see here. What we're gonna do is, in my example, we're gonna see how many 27s are contained in 1,000. So we are going to start. So first we're gonna see how many hundreds of 27. Can we have 127s? And notice that, of course, that's not enough, because if you do 127, that's 2,700, exceeding 1,000. So it definitely cannot work. So we're going to try to say how many tens of 27. And so anybody can figure out it's 30 27s, that would be great. 30 27s, that gives us a, let's say, 810. But again, it might be hard for some students to figure out that's how did you know it's 37s, and that's the maximum. You cannot do 40. And of course, we can just try 10 27, 20 27, 30 27, 40 27. You will see 40 27s are too big. So we could usually when we do long division, that's what we try to figure out the maximum number of tens we could get. So 270 and 540, it's still smaller than 1,000. 810 still smaller than 1,000. But if we do 40, that's gonna be 1,080, which exceeds. So that's the maximum number of tens we can get there. But again, here we're going to try to do something different. So we're just going to go ahead and do 10 27s. So this is 227, because 10 27s gives us 270. So that's how I got that. So this is 10 27s. And then we're going to do another 10 27s. We're going to do another 10 27s. It's kind of similar to what we did. And we add them up, we found out it's already 810, and we cannot add another 1027. Again, if we add another 270, it's going to be 1,080. That exceeds 1,000. So what we're going to do is we're going to keep adding multiples of 7 to see how many multiples of 27 can reach 1,000. Again, division means you're literally trying to figure out how many 27s are contained in 1,000. So what we do is we're going to try to do 10 27s. We're going to try to start from the answer. So are 10 27s big enough? No, it's too small, 270. We're going to try another 10 27s. It's 540, still too small. And then try another 10 27s, and we've reached 810. It's getting close to 1,000. So that's the other way to do it. Instead of using subtraction, we're doing addition. Keep adding multiples of 27 so we can reach 1,000. And notice we cannot do another 10. So now we're going to figure out single digit, like how many 27s now? 9, 1 or 2, 3, 4, 5, all the way to 9, because we cannot get another 10 27s, because that's going to be way too big. So what we're going to do is we're going to try to do 2 27s, and which is 54. And if you want, you can say, why don't we do 3 27s? You can do that if you want. It's just doubling is easier than tripling, because if you do 3 times 27, you might not be able to see the answer in your mind immediately. So that's why we're doubling here. So double 27, that's 54. And we add 54 to that, we end up with 864. And then it's still close, far away from 1,000. So we're gonna do another 2 27s, 54. And adding to that, we finally have 918, still smaller. We can still add another 2 27s, 972. Now I cannot add another 54 because if I do that, it's going to exceed 1,000 because you're going to get 1,026. Okay, so let's not add another doubling. That's not double 27 anymore, so we can only add a single 27. And after we add it, we get 999. Now we cannot even add a single 27 because if you add another 27, it definitely will exceed 1,000. So when you get here, you can pretty much stop. So you count how many 27s we have added. So these are the numbers. This is how many, the total number of 87s. So that's what 27s. That's why I add all of them up. We end up with, okay, that's a total 37 27s we did. See, 10, 20, 30, 32, 34, 36, 37. And what's the remainder? So we figure out the quotient. So this, how many 27s? It's 37 27s. But what's the remainder? Because we didn't really get exactly 1,000. We only, after adding all of these 27s, and 37 27s, we end up with 999. But if you want to reach 27, you have to add a little bit, which is 1. So this last number we added, it's the leftover or the remainder. So this 1 right here is the remainder. So that's the remainder here. And so that's part A. I'm sorry, that's the how we divide, how we use multiplication to figure out how many what the quotient or remainder is. Explain why this works, why this makes sense. So here pretty much you explain the process here. So this strategy counted by 27s. So first using 10 equal groups of 27 with 27 in each group, and then that will be a total of 810 units. Actually, I guess we did 10 groups. And there was room for 3 more groups of 27. So that's a total of 900. Well, actually, this should be 2, 4, 6, 7. So that's a 7. 7 more groups. So 2, 4, 6, 7 more groups of 27. That's a total of 999. No room for another group of 27, so we counted the total number of groups of 27 to get 37. And then whatever the number we added, it's the remainder. So here I probably should add, so first we're using 10 equal groups, and then we did 2 more we were able to add, and then add 2 more 10 groups. So that's a total of 2 more 10 groups of 27. So that's total of 810. So this refers to a total of 30 groups of 27 here. So that pretty much, this paragraph pretty much explains what we're doing here. Now part B, write equations that correspond to Meili's method work. So we want to describe this process using equations. So first we write down, okay, how did we get this? Where did 270 come from? So remember we did 10 27s. So we write down 10 times 27. And another 270, and that's adding another 10 27. And then another 270, that's another 10 27. Now then we added 54, and that's 2 27s. That's doubling 27. And then we add another 27. That's another 227, another 227. Finally, we're adding 127. So we're just writing down 27. Or if you want, you can put a 1 times 27. And finally, we are adding just a little bit of just the 1, not a multiples of 27 anymore. So after we're adding all of these numbers, 270, 270, 270, and then 54, 54, 54, and 27, finally adding a 1. All of these together will add up to 1,000. So E equals, that's why I put it right here, E equals 1,000. E equals 1,000. Now what we're going to do is we're going to count how many 27s have we added, which I already did here. So I'm adding 10, 10, 10, 2, 2, 2, 1, and that's a total of 37 27s plus the last number 1 we added, and to get 1,000. So this should be 1,000 here. And so this is how you use the equation to explain the steps.